Good morning, ladies and gentlemen. I hope you had a wonderful weekend. I hope you had a good time. It was awesome outside. As you know me, I like being outside a lot. So, sorry about that. I'll talk about being outside a lot. It is really hard to be in here working when I see it's gorgeous outside, but that's what we have to do. Before we get started on today's lesson, I wanted to catch you up on a couple things. First of all, this week is a 4-day week. Okay. You do not have school on Friday or Monday of next week. It is Easter weekend, and so therefore we are going to have Friday and Monday off. So you will have work Monday through Thursday of this week, nothing on Friday, nothing on Monday of next week. Okay. The second thing I wanted to catch you up on is hopefully by now you've already done the homework, check and reflect. And as things go along, hopefully you get more and more comfortable with that. As you might have noticed, today I had something a little different. Um, One of the disadvantages, one of the things I really miss is just talking to you guys about how things are going, what your day is going like, what I'm doing, kind of sharing some of that stuff. And so on the check and reflect from now on, I added kind of a personal touch to it. So just it says for fun, it's the last question of the guess of the check and reflect, and it just shares something of what I've been doing or my family's been doing, and asking you to share a little bit about what you're doing. And so if you feel like you want to, you're not required to, but if you feel like you want to share, just tell me a couple sentences about what's going on. I don't know if you can share a picture on Google Forms with me there. You might have to email it to me, but it would just be cool to see what you're up to, and kind of answer the question that I give you, that I share with you. So every day from now on the check and reflect, you'll see the last one will be something personal that I'm doing and kind of asking you about you and how you're doing. Okay. So just wanted to share that with you. As you see, the homework, I'm sorry, is problem 889 to 91. I'm also going to include a worksheet if you want to. The homework is on the worksheet. You can do it from the worksheet, or you can print it out and do it, or you can go to the book and do it. That's usually going to be the case. You'll have an option of one or the other. Um, your choice what you want to do. Sometimes I do it on the worksheet. Sometimes I do it on paper. Just depends on the day. So give it a shot and see what you think on that one. Okay. All right, today we're going to be working with negative exponents. Now, this is kind of a critical lesson. You see, we have 2 days. We'll start today and we'll finish it tomorrow. So negative exponents, we're going to be dealing with some of the things going on with that. So here we go. Okay. You will need some paper and hopefully your Chromebook to follow. You have your Chromebook. Okay. Uh, Here we go. Early in this chapter, you learned how to write large numbers in scientific notation. Astronomers use those large numbers to measure great distances in space. Not all scientists work with such large scale, though, however. Some scientists work with very small numbers to describe what they measure under a microscope. In this lesson, you will continue your work with exponents and then you will turn your attention to using scientific notation to represent small numbers. Now, the scientific notation is going to be on Wednesday, so we're actually taking 3 days for this lesson. Um, Today and tomorrow's negative exponents, and then Friday or Wednesday will be scientific notation with negative numbers. Okay. All right. Well, here we go. Math is described as a study of patterns, and so I want you to be open to some patterns here. Okay. Problem 875. Salvador was studying microscopic pond animals in science class. He read that amoebas were 3/10 millimeters to 6/10 millimeters in length. He saw that euglenas are as small as 8.0 times 10 to the negative second millimeters, but he did not know how big or small that a measurement that was. He decided to try to figure out what negative exponent could mean. Now, I will say, let's backtrack here just a second. A lot of people, when we talk about negative exponents, the biggest thing was like if we say, hey, we got 10 to the negative second, oh, that's negative 100, or that's negative 20. Well, what do you think? What is 10 to the negative second? I want you to give it a guess and think about it, okay? All right, now let's go back to this page here and see what it is. Now, if you notice on the right-hand side over here, we have a pattern. We have 10 to the third, 10 to the second, 10 to the first, and the 10 is always there, and the exponents are just going down. Now, 10 to the third is 10 times 10 times 10, which is 1,000. 10 to the second is 10 times 10, which is 100. 10 to the first is just 10. And every time here, one of the patterns we're noticing is to get to the next number, we're dividing by 10. So we have 10 um, or division of 10 less than that, okay? So based on that information, says copy and complete his calculations. It really would be beneficial if you copy this table down. So I will pause, or if you can pause right now and copy that table down and see if you can finish it off here, and then we'll figure it out here in just a minute. So pause, fill out the table, see if you see the pattern. Did you pause, or did you just keep going? Cheater. Pause it, and then do it. I'm watching. No, I'm not. That would be kind of creepy. Okay, all right. I assume you pause, so let's try it out here, okay? Well, as you notice, we're dividing by 10. 10 divided by 10 is 1. So 10 to the 0 is 1. Interesting. We'll come back to that. But then 10 to the negative first. Well, we're still dividing by 10. Wow. 1 divided by 10 is the same as 1/10. And then we divide it by 10 again, and we get 1/100. Work with me here. My numbers are really hard to write here. And then 10, and then divided by 10. If I take 1/100th and chop it into 10 parts again, I get 1/1000th. I want you to analyze that pattern for a second. I just want you to notice it. Okay, do you notice any patterns? Now look at what it says. How does 10 to the second relate to the 10 to the negative second? So here's 10 to the second right here. 10 to the second is 100. 10 to the negative second is 1 over 100. 10 to the third is 1,000. 10 to the negative third is 1 over 1,000. Are you seeing the pattern? I hope you are. Do you see it? Okay. What type of numbers do the negative exponents create? Did they create a negative number? No, they do not create a negative number. What they do is they make it smaller and smaller and smaller. So every time we work with negative exponents, it makes the value smaller, not negative. Okay? Let's try another example here. Ready? Here we go. I know that name's a little different. It's Nyok. Nyok was curious about what Salvador was doing and began exploring patterns too. He completed the calculations at right. So he picked some different numbers. This time he just went with 2. Okay, so again, copy and complete his calculations. Be sure to include all integer from 2 to the 5th to 2 to the negative 3rd. You could even go to 2 to the 4th and 2 to the negative 5th if you want to as well, okay? So I want you to try to do that, see what patterns you see, okay? So pause, and then fill it out. Did you? I hope you did. Okay, let's see what's going on here. Okay, if you filled it out, you should have found the following information. Every time here, what are we doing? We are dividing by 2. So we're dividing by 2, and we keep dividing by 2. Now, I can't write it very well, so I'm not going to write it anymore, but 8 divided by 2 would be 4. 4 divided by 2 would be 2. 2 divided by 2 would be 1. Now, careful here. 1 divided by 2 is 1/2. 1/2. If you take half of a pie and cut in half, you also get 1/4. And then 2 to the negative third, if you cut that again in half, you get 1/8. Look for a pattern in this list. How are the values on the right equal to the sign changing? Or to the right of the equal sign changing. So you notice what's happening here, okay? And again, you see this connection. See it? See the connection there? Okay, there is definitely a pattern. Is there a constant multiplier? Now, we're dividing, but we talked about it in class. Do you remember when we talked about this in class? Okay, dividing by 2 is the same as multiplying by 1/2. So the constant multiplier is 1/2. Okay, so I want you to start seeing that pattern. Okay, that's really important that you catch on to that pattern. Now, in problems 875 and 876, you saw that 10 to the 0 and 2 to the 0 both simplify to the same value. What is it? What is 10 to the 0 and 2 to the 0? And no, it is not 0. Both of those values, 10 to the 0 and 2 to the 0, well, look back. I mean, you copied it down, right? What are they? They are both, oh, 1. So they are both equal to 1. Do you think that any number to the 0 power would have the same answer? Explain. Well, what do you think? I mean, if we tried it with a different number, like 3 squared, or 3 to the third. 3 to the third is 3 times 3, which is 9 times 3, which is 27. 3 to the second is 3 times 3, which is 9. So 3 to the first would be 3. So again, we're dividing by 3 every time. So 3 to the 0 is 1. It does seem to work. How about 5? 5 squared is 25. 5 to the first. Oh, and you know what we're doing here, right? You're dividing by 5 now. 5 to the first is 5. 5 to the 0 is 1. So anything to the power of 0 is always going to be equal to 1. Key thing to remember there, okay? One last problem here. Both New York and Salvador are looking for ways to calculate values with negative exponents without extending a pattern. Because, yeah, making that pattern every time would be kind of obnoxious. Look at the expression 5 to the negative second. They each started to simplify differently. Salvador thinks that 5 to the second is 25, so 5 to the negative second must be 1 over 25. New York thinks 5 to the negative second is 1 over 5 to the second. Which student is correct? So pause and think for a second. Okay, no, anyway. Okay, well, they're both correct, actually. Okay, so 5 to the second is 25. So if I continue the pattern, 5 to the first would be 5, 5 to the 0 would be 1, 5 to the negative first would be 1/5, 5 to the negative second would be 1/25. So that proves this one over here. Oh, no, this one over here. However, did you notice that pattern right there? 5 to the negative second is the same as 5 squared. Well, another way to write 25 is 5 to the second power. Let's see if that worked in previous problems here. Look at this one here. Look at this. 2 to the negative third, 1/8. Well, 2 to the third is 8. So this is the same as 1 over 2 to the third. So when you have a negative exponent, it can change to a positive exponent if you put it in the denominator. That's another key thing to remember, okay? All right. That is it for today. I want to give you time to work on your homework, okay? But try to keep in mind all those patterns. There is a lot that's going to be happening. Tomorrow, we're going to be discussing a little bit more work with negative exponents and seeing if we can follow along to what they're doing there, okay? If you have questions, feel free to check with me. Send me an email. I'll be glad to help you out. If you're still confused, also feel free to watch a little bit of YouTube. Type in how do you find negative exponents, and you'll definitely find some more other videos that can help you with that, okay? All right, ladies and gentlemen, it's been a pleasure talking to you again. I hope you're doing well. Take care and share something with me. Tell me what you're doing. Tell me what you're up to, okay? All right, see you later.